Well, hi, good morning. Thanks so much for joining me here in my shop. Today is August 27th. So I haven't posted any videos for a couple of days here, but it's not from lack of work and effort. I have gone over this machine from top to bottom, left to right, inside out. I've scoped the signals, I've used my ohm meter, I've gone everywhere, done everything, and I've reached a conclusion that I'm going to try to prove today. And the conclusion, unfortunately, is that there's a frame short in the Increductor. So the Increductor is a very special coil arrangement. It's the heart and soul of this machine to a fair degree. And if the Increductor is shot, the whole machine is finished. And so my risk at taking this project on, I had hoped just an hour or two and I'd have another very interesting sweep generator. It looks like it's not going to work out. It looks like this is a dead dog. Now I think there's a lot of these for sale on eBay, oddly enough. So considering how much time and effort I put into this and how well I understand it at this point, which is pretty good, boy, I should maybe get another one. But the name of the game today is proving that the Increductor is shorted to its own case. Okay, and that's a lot more challenging than it sounds. So first of all, let me show you on the schematic, provided I can find it. Here it is. Here's the Increductor here. Now I gotta apologize right away because I have shot video for the last few days. I haven't posted it, so now I'm in a headspace where I'm not sure what I've told viewers like you and what I've showed you or what I haven't showed you. I'm really not sure at all. So I may go over some stuff here. Here's the Increductor. Here's the primary. It carries the bias current from down here and the 60 cycle AC. I shouldn't do it like that. Yeah. This is where I think the short has occurred. If I put an ohm meter here, put the other side of the ohm meter to ground, I get 164 ohms no matter what I do to this machine after that. Turn the switches, do anything I like. Pull tubes out, doesn't matter. 164 ohms. Well, we're going to prove all this again, of course. I've looked and looked and looked. There's no explanation for 164 ohms in here. There's no combination of resistors. There's nothing here. I've checked all the likely causes of that. Things like this resistor, this capacitor, this guy, all this stuff. The B plus on the tube when the set is operating is supposed to be, if I remember right, 100 volts, and it's a fraction of that. It's 20 volts, something of that sort. Where does the voltage go? So the voltage, of course, starting way back here. So it comes out of the power supply. Purpose of this tube is to sit quietly but occasionally conduct, and when it conducts it causes a drop here from the current it's pulling through, and that drops the B plus to here. That's how it's supposed to work. B plus, as I said, should be 100. It's about 20. It's a little low here, but not completely gone. It's essentially 20 here. So that's not right. That's certainly not right. How can you have a low voltage here? Because of current being pulled through this. This is a radio frequency coil with I think 175 ohms resistance. No, 750 ohms resistance. This is correct. I tested it. It's not open or anything like that. But 750 ohms, and pull some current through, you'll get a voltage drop for sure. So these guys. So what I've discovered I can do with these, it's very hard to test something like this with all these connections, interconnections and whatnot. You can rotate this switch right around until there's nothing touching any of these contacts. And they're all open. At that point you get a better opportunity to test back into here and look for problems, look for continuity, open circuit, all that kind of stuff. everything seems perfectly fine, except when I read from here to ground. 164 ohms. I believe I get 164 ohms here too somewhere, but we're going to repeat some of this. I mean, there's a capacitor right there, so I shouldn't really see the same resistance over there. The only anomalous thing I can find in all the work I've done is 164 ohms for no known reason here. That's what I'm focused on. So, as much as I want to prove it's in here, and I worked hard yesterday to do that, I really didn't. And afterwards, and thinking about it, I think the name of the game is to try to take the shell or the case that's around these coils, this metal case here. It's covered in rubber. It's black. You get a hard time seeing it. Take the case. Try to make sure the case is not in contact with the earth circuit, with the ground in here. Isolate the case, in other words, and see if the 164 disappears. I think that's easier said than done, because let's look at the way this is structured now. The Increductor is under here. Some of the contact or leads, if you like, are these copper pieces coming out here. Very, very oddly done. For some reason, not done with wires, but done with copper sheet. I don't know why they've done it this way. Some reason, something to do with the Increductor, I guess. Now, none of these should be grounded. All this stuff should be free from ground. I would think thousands of ohms free from ground. So what we're going to do, take my own meter here. It's all ready to read. Let's just turn it on here and see what we get. Make an open circuit. Oh, I can see why. Okay, it's 170 today. The very last thing I was doing yesterday was I was trying to mechanically flex the Increductor itself. Flex it a bit and then see if this resistance varied. And it did vary, 1 ohm, a little bit. I didn't really attribute it to what I was doing. 170 is different. Why would that be? Who knows? Who knows? So this is the switch that connects to all the wires coming out of the Increductor. They're all in those terminals down there. I can rotate the switch here. What do we get? No variation at all, which is really hard for me to understand, because you would think you'd be bringing in more coils and more stuff and you'd get something else, but no. 164. So what we've got here is we're connected to, I'll show you on the schematic, this is the radio frequency coil, this guy here, and we're connected right here. This 22K resistor is open. See, I disconnected it. It's open. So all we're doing is looking from here into here with the other lead of the meter connected to a grounded plate here. So this is a ground. Ground is brought up, and this would be representing the frame of the capacitor here. So this is grounded. You see some ground terminals going into the switch. What all is getting down into here? There's no indication that there's a ground wire for the frame, but there is one. I found it. Is that the only ground wire? We'll look at it in a second. So I'm going to flip this right over and take these off now. So here's a supporting frame for the Increductor. You can see a very heavy ground connection down here. I'm going to remove that. I've done this once already. I'm going to remove that and see what happens here. We'll put the ohm meter back on. I don't know if I can do it from down here. Can I do it? Go right on there. There should be a 0. Oh! Oh! How's that happen? That should be a 0. What did I do here? Well, in a sense, what I've done is I've simply read the resistance from this point again. The same point to ground. I'm just picking a different ground spot. Now let me leave that on there. I'll take that off. Is that the only ground connection? I'm using the word ground very loosely. Okay, so it's disconnected now. We got this. Didn't do a thing. Did not do a thing. That's surprising. Didn't do a thing. This is for sure is grounded. This strap connects to this strap, connects to this, connects to that point, and there it's solid onto the chassis. So we still get that reading. So there still is a ground. That would mean if I took this other voltmeter lead here, put it on the chassis, we should see 0. So this plate is still grounded. I haven't ungrounded it. Now it's bolted into a fiber plate, non-conductive plate here. You see no other connections. Let's look above. It goes into here. It's going into the insulated plates down there. There's no ground at that point. This is looking back. Let me get my meter going here. Okay, so I'm going to ground the negative lead of the meter to the chassis. We'll look for zeros anywhere I touch the chassis stuff. We should get a 0. What about here? 0. What about this? Yeah, I don't know what the is all about. 170 there. 170 there. 170 everywhere. What are these connections up here? They're going right to the stator plates. So I mean, this is so non-pictorial that it, well, there's There's two capacitors. Oh, yeah. So there's one connection to these, one connection to there. Using at different times, they use different amounts of capacitance in here. Of course, for different bands. They're not always using both. So it looks. They look identical. .164 to the chassis. Now there's other wires coming out there down below. Let's stick on one of those. Okay, that's what I would hope to see. There's no resistance between the windings. Those leads, they come up into the switch here. Really hard to sort all this out. This is the way it's been going for the last 2 days, by the way. Exactly like this. That's why I didn't post videos. So how do we know? How do I know? How do I know anything? The case is no longer grounded because when I measure it, let's just do it again because I'm really out of sorts here. Where's that case? Right here. So the case is grounded. The 164 I get up here. Hey, what happened to the one? Oh. Let's try that again. Case. And that looks like a 0 to me. Not quite. Zero's 0.2 today. Yeah, there must be something in this clip lead. Okay, back to what we're doing. So we are finding the case is grounded. Now it's 3 ohms for some reason. And then we're finding the windings giving the 160 every time. So every top terminal coming out of here that I can put the lead on, not that one. I need to touch these top terminals and get 164 ohms from all of them. So if the switch is open, which it is now, there's no contacts between any of these. I'm basically reading the first one here. They show this red and this yellow thing here, which is, I'm pretty sure, you know, red and yellow is what they're talking about there, but pictorially this isn't very correct either to me. So we have a positive right there. I'm just, never mind what I'm saying. Yeah, this isn't going well. I think I'm going to continue videoing this. I'm making very minor progress here on this. So just recognizing how this works. I wonder if when you buy this kit, if you don't get this unit partially built already. That's common in some Heathkits. They do some of the really difficult, critical stuff themselves, and it comes in the kit partially assembled. So down below here, you can barely see them down here, these terminals down here, that's the primary, if I can call it that, of the Increductor. All the secondary, and down here there's no problem, there's no short, no sign of a short, no nothing going on. Everything seems fine there. All the secondary connections are up here on top. Some of them are in the form of wires. They're very hard to see because they're black, of course, but they're down here. Those are the wires that go to the terminals here. And then up on the very top are these metal bands coming out, copper bands. Again, why they did this, I have no idea why they would do that. Why wouldn't they just use wires like anybody else would? So here's a diagram of it. Here. Did I grab the right one? Maybe I didn't grab the right one here. Grab the right one. So here you see the bands coming across. That's these pieces in here coming across to the switch. Let me see two here. One goes, what's this piece? So that piece is buried under shrink sleeve or some kind of coating here. It looks like shrink coating of some sort, something they've done. Almost certainly this was done in the factory. Perhaps it comes with these pieces sticking out here. And the kit builder is going to solder them in. Very, very weird. Like, look at that way this just, man, that's weird to me. Why exactly did they do that? So that means they're passing over the top of this piece. They're not actually connecting into it. They're just passing by. They're passing by it. And this one's supposed to be going under it, but well, there is one. You know, now that I see it, it's not 4, it's 2. I'm looking at the ends and counting it as 2. What's going on? 1, 2. This is just a metal band. Wait a minute. It's the metal band. It's not connecting at all. This is why they mention when you're in the high frequency setting on the D band that none of the coils in here are involved. And that the straps and something else, the straps and the switch, form the inductance. Okay, so this must be the straps that they're talking about. They must be talking about this. Could it, I don't know, could it be that they've gone over the top and under the bottom because that's a transformer then? I don't know. But if that's the case, then you would want these bands to be fixed in place very certainly, physically, and so maybe that's how this whole thing came. The unit came with this, and you know, you as a kit builder are trying to solder it in there as best you can. Now, so there's one over the top and one under the bottom. Isn't that interesting? Wow, now that's a likely place for a short to happen, just because it's ugly. So, you know, the short, so these bands measure at 164 ohms to ground, and I don't think that's correct. The short could be in here, because the frame is connected. No, not the frame. The stators are connected here. I'd have to disconnect these to kind of prove that the ground isn't over here, that it's internal inside here. I don't want to disconnect those. They look like monsters to try to disconnect. What I really wanted to do was kind of isolate this whole thing away from chassis ground. You know, if I manage to do that, for sure I'll get an open circuit when I do the test. I don't know if I'll be proving anything really at that point. If I isolate the whole thing away, because there's too much there. Isolating this whole thing is too much. How does it make its connections back? So there are there's a shielded wire over here. The ground does not appear up on top, but I bet you it's underneath going somewhere. We have supports coming up, but the screws are all isolated away. This is isolated. Wait a minute, this can't be isolated because it's connected to this and bumping into that. This is ground. I use this as a grounded plate, in fact. How does it get its ground? You'd think they'd do something very certain with this. Well, there's a screw post here, posted down to the chassis, so that's going to provide the ground for this metal piece. Notice they're using copper here. I think this is copper. Maybe it isn't. Non-magnetic material, probably. Non-magnetic material. Nope, it's magnetic. Hey, I like to do things that I kind of know the answer to. I didn't even know the answer to that. Okay, back to the question of how many places is this grounded. We need to look at this. There's another wire here with a shield. It would look like the shield is cut back. There's in fact, the ground I removed earlier is the shield from this wire here. Whoops. The shield from this wire. So I've disconnected a single ground here. Is there another? This other shielded wire? No, the ground is cut free. It doesn't come in here. What other wires go down? Bunch here. Well, there's a bunch here. Wires disappear. Let's look and see what we can find out about those. So our negative, so we're still grounded to the chassis here. What about these guys? No 164. Plate. The shaft here is not grounded, but it's just because it's not in contact. No, it is grounded. Well, it's bolted solidly onto this copper plate, so it's got to be grounded there. Okay, got a bunch more wires disappearing down here. Any one of those show this strange resistance? There's one more, it comes all the way up to here. Let's look at the 164 here. Yeah, 172 now. So if I were to break these two connections, wait a minute, didn't I just kind of show that there's no connection between all of this and here just now? I could have sworn I saw 164 there for a second. Didn't I unground this? Where's it getting its ground from now? Anybody show me the 164? This is grounded. And this is 100, well, why is it going up and down like that? So I'm reading 164 ohms from this to here when I think there's no connection. No ground connection. Obviously there must be more going on here. 170. $164. I mean that you know, that resistance is so consistent. It really sounds like a winding. So if I were to disconnect these 2 points, wait a minute. This is not. These points are not connected. Wait a minute. They're not connected. They're not connected to the. Now that they look like they are, but in fact, no, not on this diagram. On this one. In fact, there's a connection of the capacitor going past this. Well, I wonder if there's a short right in here. I wonder if one of these is shorted to that, somewhere under here. This isn't even the coils. This is just near the coils. Oh my gosh, really? Huh. So again, I could lift these, but you look for 164 this way or 164 that way. Really hard to get off the switch. It looks like they're really hard to get off anything. Is there some other way of doing that? So in a sense, this comes out, reaches these stator plates, and they're just floating in space. There's nowhere to go here. Same thing on this side. So if I were to lift this or lift this and then measure this, it should be just, you know, thousands and thousands of ohms to ground. Hundreds of thousands of ohms. But if there's a ground fault in here, I should be able to see it. If a set of plates here, wait a minute, these are going to two different locations here. They're going to either side. Yeah, either capacitor. Either capacitor. Of course, the moving plates are grounded onto the chassis. Grounded onto the frame. And then from there, there's a lead wire. A lead wire I never could find. It's a connection between this frame and the chassis here that I could not find. How's that work? That's an interesting thing. There appears to be a connection between all of this and here, and I cannot see it. there's a ground wire here. There's another one down here. Goes to this capacitor here. And the other side of this capacitor. So the ground lug here is connected to two capacitors. So what does it matter? You can't get a an ohm meter reading ground from something like that. They don't go to the chassis anyway. They go into the switch. So that's one ground terminal. You would think that'd be just one ground terminal on here. Now this guy, oh, he's connected too right here. Yeah, I get a 0 there. Get it open here. I've tested all this stuff many times, so that's not so good. 20K resistance scale there. 800. 0. Wait, didn't that say 800 a minute ago? Zero. Wait a minute. Oh, it's that stupid meter of mine, isn't it? Gotta be on your toes when you're working in this shop. $900 ohms. I think that's because it's going through here. And I'm counting the 164, so it's 750 plus 164, 8. That's 900. So you're 900 ohms from here to ground. Makes perfect sense. And this is right to the chassis here. So no short through here. Okay, so that's two ground connections let's call them ground connections. Now what else is in here? I disconnected the shield. Did it happen to fall back on? No, it's hanging. It appears to be hanging completely free in there, so there's no ground from here. So how is this thing getting a ground? It's getting a ground. So getting a ground back through here. No, look at this. This shaft is fiber. That's what that looks like. So you can't ground back through here. Is that really fiber? Well, up on a meter. I'm sure it's fiber. So this is also a fiber board, and they've provided isolation right here. So even though whatever this is doesn't matter. So no short through here to reach ground. Gee, there's another interesting picture right there. Oh, this shows you what's inside the a little more about what's in the Increductor. So the aluminum bracket. This is kind of reversed around. Bunch of coils down here. These are the coils that are the resonant coils. Look, they're just stuck against the. Well, this is very different from what I would imagine. So, what are these? These are the primary coils, and then these are the tuning coils. The magnetic field from these coils, generated by DC being run through these coils, is filling up the capacity, the magnetic capacity of these, and as it does, it drives down the inductance, because I guess the current hasn't got as much to grab onto anymore once you've filled it up with magnetic influence from here. That's kind of a way of looking at it, I guess. So where do you get a ground? So look at the way. So if this is built this way, these are big spools, and the wire's in here. How can the wire get from in here onto that frame? So you think the lead wires coming out. They don't show them here. The lead wires coming out of here, but they're mounted down here with a big capacitor across it. And these are all the ones coming up here. There's the choke. So they show the choke wired with wires. The choke has been stuck in solid here. Not that it really matters. It's tricky how they've done it right here. Solid as can be. It conducts current, it works fine. There, you can almost tell that it's a coil going through here. And they show the slug inside it. You can see it right there. Well, that's interesting, but it's not helping the situation at all. Where else could a ground come from? So if there's a ground in here, where are the leads that go here? Well, this is nothing to do with the 164. These coils are on the bias system. That's quite isolated away. So if there's any problem, it's got to be in here. But that's not where I'm measuring it. Oh yeah, I'm measuring it on these straps. Okay, back to the straps. So we just got to follow these. Where do they go in the circuit? Follow the straps. Follow the straps. Follow the yellow strap. Follow the yellow and red strap. Hey, it sounds familiar. Follow the yellow strap. Straight to the plate. Sure doesn't look like that. It goes into the switch here. I'm missing something. So this point is this point. And on that point is a metal band jumping over, well, jumping over to the plate. The plate's over here. Oh, here. Oh, look at that. So the stator's got a connection here, but the stator also has a connection over here coming into this tube. Well, how can that be a problem? So what do we get when we touch it? We should get the 164. Yep. Let's put this down. You see the whole 164? 172 today. The short in the tube socket. I'm going to pull the tube out. Short in the tube socket sounds ridiculous to me. Short in the tube. I've had numerous tubes in here. Nothing changes. Tube is out. Tube is out. Still connected. Oh, you've got to be kidding me. There's no way that just happened. There's no way that just happened. There's no way that just happened. I'm almost shaking here. Checking the meter. It's a 0. Are you kidding me? It's the bloody tube? No way! How can that be? What's going on there? Is a heater involved there? Pin 6 is the plate. They tested these tubes. Oh my gosh. Okay, let's hook up the meter with clips. No wonder I couldn't find this. It's the last thing in the world you would think of. Short to the heater inside the tube. Okay, I'm pulling the tube out. I'm wheeling it. I'm doing various rude things to it. Now I'm pulling it out. It's not often, I swear, but holy shit. I know where this is going. Right to the tube tester. This, I can't believe this. This is really not possible. What am I on here? 1, 2, 3, 4, 5, 6. 6 is, that's definitely 6. 6 BQ7. 6, definitely the plate. This is, well, I don't know if I've changed the tube since encountering the measurement. I think we're all set for 6 BQ7 here already. BQ7, 6.3, 4, 17L, PGK76, PGK76, 3510, 3510. So the last tube I did was this one. Shorts. This is what we'd be looking for. No shorts indicated on this tube. What if I do this? And do that and repeat that. No, no shorts showing. Okay. Everything is set. 1380, so it's going to be up around here to be a good one. And the other half of the tube. Oh, what the heck is going on? Oh, I got it. Where's my bag of tubes? What did I do with the bag of tubes? Any other tube. Any other tube. Let's put Mr. Questionable away. To reduce the chance of me getting confused here. Don't use a tube with a foot lead. Alright. Okay, any shorts in here? There is. I got the clip lead. That little leak was on the last tube I tested. May not be of any significance. It's fairly low, but oh, this is set on here. Should be here. Okay, looking for shorts. This pops up a little wee bit on this test every time for every tube. A little wee bit means nothing. How do you test? Not as strong as the other one. Okay, so it tests functional, has no shorts in it, according to this. Let's stick this in there, for crying out loud. That's what I would say. For crying out loud. I still have the meter connected. pins were a little bent on this. When you pile tubes together randomly, unboxed tubes, they start pushing the pins in just from being, bumped around and squeezed and that. This kind of tube socket is very unforgiving if the pins aren't lined up nicely. These definitely are. Okay, that looks good enough. Let's see if we can get it in there. Watch the meter while this happens. You gotta be kidding me. You have to be kidding me. Oh my god, I've just about killed myself on this. Let's put the bad one back in. This is the guy with the clip lead. Yeah, it has to be the most awkward tube in here, In the meantime, I've knocked this right off. Get that soldered back on because I think it's relied on for a ground connection. Hey, another ground. Oh no! Which one's which? Well, we'll know. We can put it in. I think this is the one that is a bad one. Shame on you. Jeepers creepers. Is this the bad one? Now watch this. Neither tube will do this thing now. Oh, come on. Okay, so maybe I just got them all mixed around in my hand here. Son of a gun. Don't make me all mixed. Okay. The meter better drop on this tube going in or I'm in some kind of a... Oh my god! What's happened? Something inside that... I can say something inside the... I fixed it. I have fixed it. No, the meter maybe has come off. Maybe the meter's come off. I'm reading nothing. Ah! It's good, it's good, it's good, it's good, it's good. You need this to be on. Well, what did I have this clipped on? I had it clipped on here. How come it came off? 164. There it is. Okay, so this I think is a bad tube. Oh, wow. Thank God I'm not a doctor. Nurse, would you hand me the heart, please? Oh, doctor, I gave you the heart 5 minutes ago. Oh. There it is. Okay, you're getting a clip lead. This tube tests fine on my tester. Clearly has a serious short in it. Let's put this one in. I can't believe it. This is what it's come down to? Do you realize I spent the last 2 days utterly convinced there was a short in the Increductor? But I know I'm not 100%. Oh, wait a minute. Hold it. Hold it. Hold the fort. That clip lead must have popped off just at the wrong time before. Okay, something stupid's happening here. Okay, Jim, you're stupid. What are you doing that's so stupid? What are you doing? First, let's just count the pins. Count the pins. We're not on the pin. I think we're on. Give me a pointer. Okay, starting here. This is 1. Is it really? Yes, it is. 1, 2, 3, 4, 5, 6. I am on pin number 6. Pin number 6 of the 6BQ7. Pin number 6. That's 6. 1, 3, 8, 7. That's 6. Pin number 6 of a 6BQ7. That's where I'm clipped right now. Which uses the yellow strap over yonder. You know, I can't operate this. I don't have this 22 connected. This 22 is disconnected right now. I gotta remember that. Well, that just seems to me I went right around the bend crazy. Now, how is it you can pull this tube out and have any influence? Well, there's just a plate here. How can it possibly make any difference? Pulling this tube out. Well, in a world where sometimes really strange things happen, this should not happen. 6BQ, 6. 6 is a plate. There's just no way that could be wrong. 6 is a plate. $164 to ground. Pull the tube out and it disappears. What's connected to this plate is a capacitor, and it's always, you know, almost always, it's 172 to 164. I wonder why it likes those two numbers. Why does it like those two numbers? We don't know. Oh, I thought it was right on it there, boy. I was pretty excited. I get inconsistent results plugging in and out these tubes, and I think it's simply because this clip lead fell off and I didn't see it. It's another false reading throwing me off base here. Okay, so we think we have a perfectly fine tube in here. In fact, all these tubes appear to be perfectly fine. How is it you can shove a tube in there and develop a ground? So I did see a situation, I don't know if it was in here, and it could have been me who did it. It wasn't. It was somebody else did it. They soldered a wire across the top of the, like this one, like these wires going across here. It's so far down that when you put the tube in, the tube pin popped out and just about touched the wire. It didn't touch it, but it opened my eyes to a possibility. And it would be true in this case, because you pull the tube out and the short disappears. Does it really? I mean, this is so unbelievable. 172, pulling out the tube. And it has to be the hardest tube to pull in and out. Look at that. My head is going to explode. I would just shove any other tube in there. Any old tube. Give me an any old tube with the same number of pins, of course. Does it matter? This is a nice long tube. It's a little easier to handle, maybe, in there. This is stupid. I'm in it. Okay. I've gotten into some weird spots doing this work, but this is really high on the list. Any old tube. Any old tube. What about any old thing? What if I just shove something into the socket? The proper pin. Guess what pin 6 would be. I have to count the other way now. 1, 1, 2, 3, 4, 5, 6. This is pin 6 here. I think it's pin 6. Is it really pin 6? Sorry, banging my head on the microphone there. I can't believe what I'm doing. This isn't the best tool. I can't plunge it all the way down. How about something like this? I'll take a stiff piece of wire here. I'll just, that's roughly the size of a tube pin. Shove it in there. Okay, now which one again? One, 2, 3, 4, 5, 6. Pin 6. Right in. Didn't do a thing. Did I miss? What about this one? What about this one? I'm laughing. Here's another one. Let's try another tube. 6BQ7. This, I believe, is the original tube. There's something I really am messing up on. How the heck can this be? Oh, it's really getting painful. It's just a plate in the tube. Just a plate sitting there. So all I'm doing when I plug in the tube is adding this little piece of metal. I'm adding a little piece of metal here, but the test may be coming around to other things. The test current could be going somewhere else. 164 sounds like a heater resistance. They don't show the heater circuits on here. They're very simple. The tube we're talking about is a 6-volt tube which just has one heater in it. What's the resistance of the heater? It's between pins 5 and 4, which is typical. What? Just pick any one of them. Between pins, I think this will do it, 5 and 4. Ooh, I gotta think hard now about which way this tube goes. So if we're looking at the bottom of the socket, we'd be looking at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 6. What am I reading it to? Like, what am I doing here? I don't even know what I'm doing. Oh, heater. Yeah, coffee's wearing out here. So we wanted to do, what did I say it was? 5 and 6? 4 and 5? 3 and 4? It's 5 and 4. So that's 5. This will be 4. Wait a minute. 1, 2, 3, 4. What did I do? 4, 5. Put it on 6 for some reason. Okay, man. What's the resistance of the heater? 2.3 ohms. Wow, that's nowhere near 164. Is that correct? I don't know. Sounds reasonable to me offhand. You want to develop some wattage? You're going to put in 200 milliamps. You have 400. I don't know. I don't know what to think. I really don't. I mean, this is like not making sense to me at all. I think I'm right on top of what's going on now, and the good news is it may not be the Increductor. What the heck is going on? You know what? It's break time. I gotta stop for a while and just let this cook in my head. There's something really weird here. Yeah, it could be me. Okay, so in studying this and thinking about it, how can plugging a tube in change anything? Because all the elements are nowhere. They don't go anywhere, right? The tube's not operating. No current flow in it. Doesn't matter what tube I put in. Get the same result. All I'm doing is extending the wires just a touch. Except in one case, and that's the heater. The heaters. They're not shown up here. Of course, they're all shown here. There is a ground on one side of the heaters. I measured the heater resistance. Was it a couple ohms? Is that correct? I don't know. I'm not sure that's correct. 164 ohms would be nice. Would suggest something to me. So how does the ground down here somehow have an effect up there? With different tubes, and even a totally different tube. I put in a 6. Yeah, see, I put in a 6CL6 for fun, where the 6BQ7 goes, and when I did, I got the same result. But see, the heater pins are the same, 5 and 4. If I picked a tube with different heater pins, I'm willing to bet you wouldn't have seen this effect. So what does that mean? That means a short right in the tube socket somehow? How would that work? How does pushing pins through the contacts? So the heater gives you access to the ground. So would it be the ungrounded side of the heater has somehow become grounded? Well, that would mean the heater wouldn't even heat. Well, this tube heats up, doesn't it? Doesn't it heat up? Son of a gun, you know, it's hidden from view. Those are interesting things. Well, let's see, the tube is in right now at pin 5 and 4. If we read to ground, we get a 0 on 1, and we'll get the tube resistance of all these guys in parallel. So we get almost a 0 on 4. So we get a 0 on 5 and almost 0 on 4. 0 on 5. 0 on 5. 0 on 5. So this is 5. We get a 0. On 4, we get the same thing. We are getting somewhere here. Now for sure, this is 5 and 4. 1, 2, 3, 4 and 5. 4 is 0. 4 is 0. On the 2K scale. There's that. Oh. Okay, you know, once again, this meter will give you the reading you want. Just keep fooling with it. There. You get the reading you want. Okay, if I pull this tube out, what should that do? Shouldn't do anything. Should it? Shouldn't really do anything. Should it? What happened? How come I went right to 0 there? So we get a 0 here. We don't get a 0 there now. Well, we don't know what 0 is on this meter. Whoops. We don't know what 0 is on the meter. What is 0 on the meter? Well, today, 0 on the meter is somewhere between 3 and 5. Even as high as 7. One side of the heater should give a 0. The other side should not. Now you got it backwards. Well, not according to this. They actually tell you which one. It's 5 should be on the ground. I got too many clip leads in the circuit here, probably. That's probably what it is. Wow, they seem pretty stable. Shouldn't that be a 0? Checking the 0. Checking the 0. 0.4. 0.4. Should get 0.4 there. What is going on? Yeah, that looks like a 0 there. That's on 4 though. That's on 4. Well, of course, as I said before, going through all these different tube heaters. Pull out all the tubes except the one in question. It's easily done. That shouldn't do anything, I don't think. So this should be raising the resistance of this line as I pull these tubes out. Now there's another guy over here. This is the no, this is the added in one. This guy has his own heater circuit. There's only one more tube left besides this. Come on out. It's just very hard to get a grip on this tube. All that's left now is the tube in question. So before I do anything, let's just look at all these pins on here and see if we get another one that does a 0.6. Heater, other heater. It's backwards to what it shows on the schematic. We should get a lower reading here. So it sounds like ground on here. 0.6, and the ground reading rate at the moment is 0.4, 0.6 pieces of wire. .6 on the 200. It's 0.6 ohms. We are talking about a short here. Now I'm going to pull the tube out. There's going to be no tubes left in it. Maybe I should try operating it with no tubes. I might have better luck that way. Open. So what's this mean exactly? Because the grounded solid on pin 5. 1, 2, 3, 4, pin 5. Whoops, I really blow that time. So that's interesting. So there's no connection now from pin 5 to ground, at least nothing like that. It's as if the heater's been wired backwards on here. The other heater gives you a 0. You need a 0 on 4 with all the tubes pulled. So you get a 0 on 4 because you can go right through the transformer. Pilot light's the problem. That's all that's left in there. Now there's no connection. There's no heaters left, no connection. So all we're reading now is from here through here to here. That's what that has to be. So we go pin 4, first pin 5. Oh, my meter's gone sick again. What a crazy meter. Time for a new meter. This is just becoming so unreliable. It's outrageous. Five, open with a capacitor. 4 has a short rate on it. Now it's on 20K, so we'll take it down to 200. Working? Seems to be, and the 0 now is 0.5. We go on to pin 4. It's pretty darn close to it, dead short, isn't it? So who cares if the heaters somehow are turned around? Why would that even matter if these were turned around? I have some trouble understanding why that would matter at all. Other connections coming here, just there's nothing else hooked in here at all. All tubes are out. Now we're good on the 164 is gone. How can the heater get involved in this? I mean, it's specifically designed so the heater doesn't get involved in the operation of the tube or the radio. Its job is just to heat the cathode and do nothing else. Some kind of short circuit has occurred. What kind of short circuit could develop? What could happen? You know, this unit was operating, seemed to be operating fairly well, in fact, early on. I left it operating for a period of time, left my shop, and when I came back in, the output was gone. So you would think, okay, something popped open, something shorted out, something dramatic changed in it. Maybe not, because oscillators are kind of sensitive. A bit of a knife edge circuit. You got to get everything right to get them to oscillate. Wow, this is just has really gotten weird. Yeah, it's really gotten weird. So if I measure the resistance inside each one of those, each pin in the socket here, I don't have to measure it by pin. It just seems like you got to put the tube in to get the effect. Okay, so this is resistance to ground. Starting with the one where we get 164. It's gone now. I'm just gonna start at pin 1. I better put this up here a little bit higher. Say 20K. Checking the meter. Good. 20K. What do you say? 240 ohms, and this is on the lead. Basically, it looks like it's carrying the signal away. I'm not sure what that is. Shielded wire there. First heater. Second heater. The tube is out. Plate. Next. Next. Last. Measure the tube heater resistance better. It's 4 and 5. .200 scale. For a minute, I thought I was going to say 164, but there's that 2 point something ohms again. I don't get 164 ohms out of any of these. Some weird paralleled combination of resistors combined through some kind of short or something like that. Let's see this thing happen again. So we'll put this on the ground. That's the negative to my meter, and we'll clip this onto the plate circuit. And we will then take this tube and we'll stick it in there. If that meter drops, it's time for lunch. That's what's going to happen here. It's very, very hard to use these. This kind of tube socket is really terrible. There we go. Ah, look at that. I just... I thought this would be easy as pie. It's just gotten weird again. It's another day in here. Things getting really weird. There must be some other combination here I'm not picking up on. How can you plug in a bunch of, you know, it's like adding a 1/4 inch of wire to each of these spots. It's not going to do anything. There's nothing being connected when the tube goes in except the heaters. Like connected through. Basically, nothing changes. You put this tube in and out except the heater circuit. I'm measuring pin 6, but that could be effectively the same as, well, it can't be the same as, there's a capacitor there. That's another thing. There can't be a capacitor in the circuit that's my meter's measuring. Unless there's a capacitor with that kind of resistance. But I mean, look how stable it's been. How do you get to 170 ohms every time? Well, 164 to 170. Maybe you add, that's 100K. No. I don't know. I've asked myself these questions over and over. This is really strange stuff. But you know what? I think I'm going to have to stop there. I think I will dare to post this one. And because I think it's pretty curious. And I'm going to go have my lunch. So thanks a lot for watching. And yikes.